All right, and welcome back. So today we are going to be talking about what are called non-linear systems. Now, previously, going back earlier in the year, we talked about solving systems of equations, and we had two linear equations. Now that we've talked about quadratic equations, let's connect linear and quadratic together. We're going to be talking about non-linear systems. So a nonlinear system of equations is a system in which at least one of the equations is nonlinear. And we're going to have three possible solutions for a linear quadratic system. That's when we have one linear equation and one quadratic equation within the system. Now, we could have the possibility where there are no solutions because our line and parabola are not going to intersect. Thinking back about solving systems of equations by graphing, we looked for the point of intersection. Well, we don't have a point of intersection in that first example of no solution, so we don't have a solution. We could have a one solution system, which is when we're going to have our line and our parabola intersect at only one point, or we can have a two solution system, which is where our parabola and line are going to intersect twice. So let's solve the system by graphing. And let's make sure to check our answer. Let's say we have this system here. Y is equal to x squared minus 3x minus 4, and y is also equal to negative 2x plus 2. We want to find the possible values of x and y that satisfy this system. Well, we're going to first graph our parabola because that is the first equation within the system. So we're going to graph that quadratic function, turning it into a parabola. And within that, we go through the steps on how to do that. Step 2 is we're going to now graph our linear equation, our line that represents that slope-intercept form equation. And again, we go through the process of how to do that. And then we're going to find the points of intersection. Well, those points of intersection look like they are 2, 6, and 3, negative 4. Again, we're just identifying the points of intersection, and then we can substitute the solutions into each system and make sure that we have true statements. So as we check, we substitute in both of our possible solutions, verifying that they are indeed true by ending up with a true equation, and we see that both points of intersection are indeed the solution to our non-linear system. With this in mind, please work on problems 1 and 2 on the guided notes and turn over to the back when you're ready to move on. So we can use algebraic methods to help solve a non-linear system just like we did with systems of equations. Now, we're going to solve it by using substitution. So let's say we have a quadratic and a linear equation. We have y equals 3x squared plus 2x minus 1, and y is equal to 2x plus 2. Again, we're looking for the x and the y that satisfy both equations. Now, we could have either one solution, two solutions, or maybe even no solutions. So we can use substitution because both equations are solved for y. So we can substitute 2x plus 2 for y. Or we could have done 3x squared plus 2x minus 1 for y. We're using the substitution method here, and now we're going to solve for x. As we go on through, we're going to find that we have 3 times x plus 1 times x minus 1. You also could have solved this using square roots. If you added 3 to both sides, you end up with 3 is equal to 3x squared. We divide both sides by 3. We end up with 1 is equal to x squared. So we end up with x is equal to positive 1 and x is equal to negative 1. So there's a lot of different ways that we can go about solving these systems. You could have used the quadratic formula. You could have completed the square. But once we get into a spot where we're going to find those specific values of x, that's where our personal choices come in here. Now, for me, again, I would have went with using square roots. I would have isolated that x squared term and saw if it was a perfect square. Now, you might have wanted to use the quadratic formula. That's totally fine. That's totally fine. Now we're going to write in the original equation, we're going to substitute in to get those y values. we end up with -1, 0, and 1, 4. Now we can use a graphing calculator to check our answers, and it does support our solutions. So we can use these algebraic ways of solving these systems. We went through an example of substitution. Now, on your guided notes, what I'm going to ask you to do is work on problems 3 and 4. Problem 3 is another substitution. Problem 4 is elimination. So I'm going to ask that you try out problems 3 and 4. We didn't go over how to use elimination within a nonlinear system, but think about how we've solved it previously and see if we can interpret how to solve it with a nonlinear system. You got it. Try it out. So please work on problems 3 and 4 on the guided notes. Y'all again are working super duper hard. Keep up the great work. Keep making yourself proud. Challenge yourself with problem number 4. Don't just start it and give up. If you don't get it, try it again, because I know you can do it. It's just, you have to think a little bit, and you're going to be okay. We haven't talked about systems in a while, so we may be a little bit rusty. That's totally fine, but try it out. You can do it. I know you can. But if you have any questions, please make sure to jot them below, and I'll talk to you soon.